Today, we will learn a new topic in mathematics, logarithm. There are many mathematicians involved behind this logarithm. One of them is John Napier from Scotland, and another one is from Just Berge, and then we have Henry Briggs. These three mathematicians are responsible. There are many other mathematicians involved, in fact, for the logarithm that we are going to learn. This one is the book of logarithm by John Napier. These are the books will look like. And this one you see here is actually the Clark's table. That's the table that we used before we used calculator. We used this table before calculator. We used calculator. And in the modern calculator that we are having used, there are three buttons, and there is a button here called a logarithm. You can see there is a logarithm and the base and the two squares. We are going to use that button in our logarithm. Um, Remember that logarithm in our daily lives we use for in chemistry to find pH value and then to calculate the Richter scale. In finance, and we will learn when we learn finance how to use a logarithm to find n.
Now, let me explain to you why we use logarithm. We know 2x plus 1 is equal to 0. This is a linear equation, and we know how to solve this linear equation. We know how to make x the subject of the formula and solve it. We also know x square is equal to 4. Then we know how to solve. And thus, for solve for x, we take the square root on both sides. We know x square is equal to 64. We know how to solve for x. We know how to make x the subject of the formula. Now, if it is 2 to the power of x is equal to 64, how we are going to solve this? One of the methods, we try to make equal bases, but it may not be possible if 2 to the power of x is equal to 70 or 2 to the power of x is equal to 100. We may not be able to solve for x. Now, the purpose of logarithm is to make this x the subject of the formula. That's what we are going to do now. So, a logarithm is another way of thinking about exponents, which is very important. Let's look at the exponents that we know. 2 to the power of 3 is equal to 8 is an exponent. 10 to the power of 2 is equal to 100 is an exponent. Now, in these exponents here, in general, we write b to the power of x is equal to y. B is called the base, x is called the power, and y is called the a number, the value of that expression. Let me come again here. 2 to the power of 3 is equal to 8. 3 is called the exponent or the power. And 2 is called the base. So an exponent, a base, b to the power of x, we have a power and we have a base. We have a base in the case of the exponent. Now, as I said, logarithm is another way of thinking about exponents. So we are going to make the power the subject of the formula because we want to solve for here. Here we want to solve for x. So we want to make x the subject of the formula. So how we do that? B to the power of x is equal to y. I make x the subject of the formula is equal to log, means logarithm of y to the base b. This is how we write the log. This is the definition of a logarithm. I'll explain once again here. B to the power of x is equal to y. I make x the subject of the formula and I write equal to logarithm of I to the base b. How we read it? We don't read log b y. We read it as logarithm. Logarithm of y to the base b. That's how we read it. Logarithm of y to the base b. Let's see how we use it in our calculator. 2 to the power of x is equal to 64. So we are first we make x the subject of the formula, right? So I bring this x here, the subject of the formula. Then I write equal to, then I write equal to, and I write a logarithm, and I have to bring this and there's 64 here, and I bring this 64 here, right? And I have a base, and I have a base. And I bring the base here. This is how I write the logarithm. Now, how am I going to solve it? Yes, this is my calculator here. Um, you can see the calculator, my Casio calculator, and this is my key for logarithm here. You can see that this is a key for logarithm that I'm going to use. I press that one here. You can see my base. My base here is 2. So I will say this is going to be my 2. So this will give me 2. And then what I have to do, I have to press this arrow key so it comes to the next box, and I type 64. Yes, and I am done with it, and I press equal to. So I get the answer is 6. That's how I solve for it. Where's my pen? X is equal to 6. You can also solve, 2 to the power of 6 you can make as equal bases. You will get the same answer. You drop the bases or equate the exponents for equal bases, and you get x is equal to 6. That's how you use logarithm. Important points on logarithm. Let's understand these points. Um, we know the definition. We have seen that b to the power of x is equal to y. Then where b is positive, where b is positive, then logarithm, by laws of logarithm, we have seen that log of y to the base b is equal to x. We had made x the subject of the formula. This is what we have seen. Now here b is positive. We are not learning where b is negative in the case of exponents. So also the logarithm is only defined for positive bases. In other words, logarithm of a negative number is not defined. When b is positive, then y is also positive. Therefore, logarithm of negative numbers is not defined. That is a very important understanding you must have. So let me write down that understanding here. Logarithm of a negative number is not defined. So this is a very key understanding for us. Logarithm is defined only for positive. Logarithm is defined only for positive numbers. So logarithm is not defined for negative values. It's defined only for positive values. When b is positive, y cannot be negative. Y is positive. Therefore, logarithm is defined only for positive values. Now, just as we have laws of exponents, we will also have laws of logarithm. However, I am not going to explain the laws of logarithm as they are not examined, but we must know certain laws. For example, log b to the base b is equal to 1. It originates from the exponent b to the power of 1 is equal to p. So we relate this experience from our exponents, and we apply to logarithm. Second one is logarithm of 1 to any base is 0. It again originates from our laws of exponents. B to the power of 0 is equal to 1. Any base to the power 0 is 1. Similarly, logarithm of 1 to any base is equal to 0. Now the third one,
is negative of logarithm of a number is same as logarithm of the reciprocal of that number. So here it is, logarithm, negative logarithm is as will be a logarithm of the reciprocal of that number, the same base. Let me take you to one example here. For example, logarithm of 3 to the base 2 is same as logarithm of 1 over 3 to the base 2. Now, this is also similar to, for example, logarithm of 3 to the base 2 is same as logarithm of 3 to the base 1 over 2. So both of them, I can write this in both of them. Negative of logarithm x to the base b can be written as logarithm of reciprocal of x, that is 1 over x to the base b, or I can also write as logarithm of x to the base 1 over b. So either I take the reciprocal of the number or I take the reciprocal of the base. So these three laws must be understood very clearly when we apply in our exams. So we must understand these laws when we may require them to apply in our when we attempt problem solving. Now let us look into the type of questions that we come across. F of x is equal to 3 to the power of x. Write down the equations of f inverse in the form of y is equal to. Therefore, here my f of x, I'm going to attempt this answer here. F of x is given to be 3 to the power of x. The question is to write now in the f inverse. Therefore, f inverse of x. So f inverse of x involves two steps. My first step is I write y is equal to 3 to the power of x. I interchange. My first step is I interchange x is equal to 3 to the power of y. So it's my first step. My second step involves making the y the subject of the formula. This is where we apply the laws of the definition of logarithm. So x is equal to, I have to make y the subject of the question is in the form of y is equal to. Therefore, I have to make y the subject of the formula. So y the subject is a power, though I use here log x to the base 3 is equal to y. I apply the definition of logarithm to make y the subject of the formula. So it's always better to write y is equal to log x to the base 3. So this is how I get my solution, my first one. Now the question here is sketch the graph of f and f inverse in the same set of actions showing all intercepts and asymptotes. So now here first let me show let's discuss on f of x. The best method whenever you are asked to draw an f and f inverse, I would recommend that you use the table method. It's easy to understand. So x and y, I'm talking about f of x. I put x is equal to 0, that is 3 to the power of 0 is 1. When x is equal to 1, that becomes 3. When it's negative 1, it is 1 over 3. When it is 2, when 3 square, which is equal to 9. So I plot these points, and we know here asymptote here will be, my asymptote is going to be y is equal to 0. Therefore, I write y is equal to 0. Now, let us plot these points on the graph here. 0, 1. Then we have 1, 3. Then we have negative 1 or 1 over 3. Maybe somewhere here. And 2, 9, 2. This is 1, 2, 3, 3, 6, 7, 8, 9 will be somewhere here. And so this is my graph for f of x and 1 point here. This is my 1 and 3. So, and this is my y intercept. There's no x intercept, and my asymptote will be y is equal to 0. So this is my asymptote. X is equal to 0. Sorry, y is equal to 0. Sorry, where is the eraser? Okay. So this is my y is equal to 0. Yeah. What is happening? Yeah, this is y is equal to 0. Now I have to plot the inverse. So when I want to plot the inverse, what will I do is that for f inverse, my asymptote will be x becomes y becomes x for the f inverse. So this will now become x is equal to 0. And as I have said, x becomes y becomes x. So here, this is 1, 0. So this 1, 0 will now become 1. 0, 1 will become 1, 0. 1, 3 will become 3, 1. 1 over 3, negative 1, 9 and 2. So here you must note that I have swapped the values. I had swapped the values of 0 and 1. It becomes 1, 0. 1, 3 will become 3, 1. Negative 1, 1 over 3, 1 over 3, negative 1, 2, 9 will become 9, 2. So that's how, now I have to plot them. So now I plot them. So y intercept will become x intercept. So this is my, let me take another color pen so it becomes easy to understand. So it becomes x intercept. Then we have 1 over 3, 1 over 3, 1 will be somewhere here. And then 3, 1, 3, 1 will come here. 9 and 2, this is 3, 4, 5, 6, 7, 9, 2 will be somewhere here. 9, 2 will be somewhere here. Now I join them. So this graph will be my f inverse. And of course this is my EF. And we must also write the asymptote x is equal to 0 for the f inverse. And 1 point here, 3, 1 will become 1, 3. So this is how we sketch the graph of f and f inverse. So I think it is clear now. Let us look here. 3 to the power of negative x. If y is equal to 3 to the power of negative x, I can make a negative subject of the exponent subject of the formula. So negative x will be equal to log y to the base 3. I hope you are agreed. Or x is equal to negative log y to the base 3. I hope this is clear. Now similarly, I can rewrite this y is equal to 3 to the power of negative x as by using the laws of exponents. Now I make x subject of the formula, and when I make x the subject of the formula, I will write log 1 over 3 y when I make x subject of the formula. So same principle I apply this principle here, and when I say negative of log phi x can be written as logarithm of 1 over phi the base x. So I want you to compare these two things here that I have done here. I want you to compare these two here. That will tell us that negative of log become log base will be 1 over 3. Therefore, I can write like this. Therefore, here for my first answer to the first question, it will be f of x is equal to log x to the base 1 over 5. Question number 2 is to find f inverse. Of x. That means my original was y is equal to log x to the base 1 over 5. Therefore, I have to swap the values. X is equal to log y 1 over 5. Now I have to make y the subject of the formula. Therefore, f inverse will be the exponential function. That is 1 over 5 to the power of x is equal to y. So I change the logarithm to an exponent. So we must know both from exponent to logarithm and from logarithm to exponential form. As I said, logarithm is another way of looking at an exponent. So we must be able to interchange exponent to logarithm and logarithm to exponent. We must understand now here is that inverse of an exponential function is logarithmic and inverse of a logarithmics is exponential. Inverse of an inverse is the original function. Now the question number three is to draw the sketch the graph of f and ef inverse is the question. So what I'll do, f inverse is an exponential, so I'll start with exponential. That is a better way to draw a logarithmic graph. So here I'll say x and y. Remember, I am looking at f inverse. So when I put x is equal to 0, I get 1 definitely. And if I put 1, and I will get 1 over 5. And if I put negative 1, I should get 5. So I got these points for f inverse. Now for f inverse, yeah. Now for f, it is now easy for me. I just need to swap the values of x and y. So here is 0, 1. This will now become 1, 0. This is 1 and 1 over 5. So it's 1 over 5, 1. And this is negative 1, 5. And this is going to be 5 and 1. And f inverse being an exponential function, and I will have my asymptote will be y is equal to 0. And in the case of f, my asymptote will be x is equal to 0. We just need to swap the values for f and f inverse. That's exactly what I have done. For ease of understanding, I started with exponential function. Now to plot these points here, I need 0, 1. So 0, 1 is somewhere here, 0 and 1 is somewhere here. 1 and 1 over 5, 1 and 1 over 5 is here. And negative 1, 5, negative 1, 5. So this is going to be my graph of f inverse. Definitely this is my y is equal to 0 is my asymptote. Now let me also put a point here 0, 1 and negative 1 and 5. Now if I want to sketch the graph of f 1, 0, 1, 0 here, 1, 0 will come here, and there is 1 over 5, 1, 1 over 5 somewhere here, 1 over 5, 1 will come here, and then 5 is 1. Something went wrong, 1, 0, 1 over 5 will be 1. So sorry, this here is negative 1 here, sorry. So it is 5 is negative 1. So 5 will be negative 1. Which color I'm using? Green color. So 5 will be negative 1. So graph is going to be like this. So this is my graph for EF of x. And I also plot the points here. This is my 5, negative 1. And this is my 1 and 0. That's how we sketch the graph of f and f inverse. I have to make the asymptote, which is equal to x is equal to 0. So these are the two graphs for f and f inverse. I started with f inverse because it's an exponential graph, and just for a logarithm I swap the values. That's how I sketch the graph of a logarithm and this exponential graph.